Hello there everyone, and welcome to another edition of Starry Skies, the magazine programme that tells you all about what's in the night sky in this warm spring month of May. I'm Mark Hardaker.
And I'm Steve Tonkin, and in this month's show we're heading out under hopefully warmer late evening skies to explore what May has in store for sky watchers here in Dorset and Hampshire.
Absolutely, and we're going to talk today about that dud comet. We talked about a comet last month, didn't we, Steve?
We did, and we predicted dudness.
And we did, and we got it right.
We did.
So it had a close brush with the sun, so we're going to talk about that. And we're going to talk about the meteor showers, which you may have seen in last month, and we're going to have another one this month.
Yeah.
The 2 full moons this month, and the return of the summer constellations, if we can see them, because of twilight.
Right. So we're going to talk about twilight, one of my favourite topics.
Yeah.
I love twilight.
So, well, why don't we start with that? Because every day since the clocks went forward, nights have been getting shorter.
They have, and if you go out after sunset, well, there's still stuff you can do for nearly an hour at this time of year.
Yep,
and that's called civil twilight. And
are you being very civil? Do you have to be civil?
Possibly, but it's when you can carry on normal daily activity and there's enough light in the sky to enable you to do it.
Right.
So particularly important for agricultural workers and that when this came in.
Right.
It was also the time, if some of the older listeners may remember, lighting up time.
It used to be in the paper, didn't it? The bottom of tonight's lighting up time for putting your headlights on. Nowadays, the headlights are on all the time.
Well, yeah. Well, they should go on nowadays. They should go on at dusk rather than at the
twilight.
end of civil twilight, which is how it used to be.
So civil twilight's first.
Yep.
Okay, then what?
No. We don't not know then what. We still look, but don't look at the sunset side. Look into the east, and you should see this pink glow if it's a nice clear sky above the grey.
That's opposite the sunset.
Opposite the sunset.
Uh-huh.
And it's really worth looking at. It's called the Belt of Venus. And you're watching that darkens and darkens and darkens until the next phase of twilight, which is called nautical twilight, for reasons that Mark will describe in a moment. And then that goes purpler and purpler, and eventually it just fades into the sky. It's really lovely, the colour change.
So nautical twilight, as I understand it, is when, it's obviously for sailors, when they can detect still the difference between the sky and the sea.
That's right.
So in the old days of navigation at sea with sextants and other optical equipment, they had to be able to pick out the stars and pick out where the horizon was, and when nautical twilight starts or finishes, we can no longer detect.
You no longer see the horizon, so you can't use things like sextants, where you use the mirrors actually to bring a star down to the horizon,
right? And
then it tells you how high up it is, and then you can use these massive manuals to try and find out where you are.
So after that, it's getting darker and darker.
Yep. And
then we have astronomical.
Then we have astronomical twilight, and at that time, it's when you no longer see colours around the ground. Everything goes to shades of grey, and it's because we have two major receptors in our eyes. There's the cones which detect colour, but they're not that sensitive, and then the rods which just detect light and dark, and they are much more sensitive. And when there's very, very little light, that's what we detect. We just detect light and dark, and that's wonderful.
Yeah. So that's astronomical twilight, and that's officially defined, isn't it, Steve? By the distance the sun is below the horizon?
The sun is between 12 and 18 degrees below the horizon. A degree is about twice the width of the sun, so you can sort of imagine that.
So at 18 degrees, that would be 36 times the width of the sun below the horizon.
Yeah.
Right, I got it now, yeah.
Then, if you're somewhere really dark, then you no longer see a sun's glow on the sunset horizon, and the light of the sun is taken over by other light, which would be either you get a slight glow from the aurora, you get reflection of dust in the solar system, of stuff in the galaxy, all that. But of course, for most people nowadays, unfortunately, that's all overtaken by another form of light, which is light pollution.
Yeah, it's a shame. We try our best, on this show to highlight what you can do to avoid light pollution, and that is having the right light at the right time.
It is. It's not about just turning all the lights off. Nobody with any common sense wants that. So, sort of don't have a light that's too bright. Go for warm colour temperatures, so the ones that look sort of slightly yellowish or orangey, because they're much, much better for most wildlife and actually for us at night.
Yeah.
And have them on active controls like timers or motion sensors, so they're only on when you need them.
Yeah.
And then, of course, shine them where you want them.
That's it. Yeah, so a shade that directs the light onto your footpath, not blasts up the side of your house, for instance.
Yeah, indeed.
Yeah, and that's to protect not just poor astronomers like us. We're a tiny little percentage of the population, but it's for everybody else there, our mental health, well-being, as well as, of course, our butterflies, our moths, and our birds.
Indeed.
Yeah, so astronomical twilight. So here in the south, Steve, from the 27th of this month, 27th of May, there is no proper darkness anymore.
No proper darkness right up until mid-July.
Right, till the 18th of July.
Yeah.
So that's when the sun never gets that 18 degrees below the horizon. So we don't have a properly dark sky.
No. I mean, there are benefits from it, and one of them we can talk about next month when you'll see them.
Yes.
We're just a little hint forward there. Things called noctilucent cloud phenomena.
Yeah, very, very
nice. Tell you
nice
about
to
those
see.
next month.
Yeah, that will be in June.
Yeah.
Also, the further north that you are, the worse it is. So I'm from Keighley in West Yorkshire, as you can probably hear from my dulcet tones, at 54 degrees north. And up in Keighley right now, from the 13th of May until the 1st of August, there's no darkness.
Yeah.
But how about poor astronomers in Aberdeen? Poor fellas.
Yeah.
Well, they have nothing from 1st of May until the 13th of August. There's no darkness, so...
Yeah, so they can only see the brightest stars. And as spring and summer progress, see fewer and fewer and fewer stars.
Well, that's why they're in the pub all the time with that whiskey, those Scots people. But
it's very nice. Although I must say I prefer the Islay one, but hey.
Anyway, so we do have time this month to still enjoy the night sky.
Yeah.
And here in the south, at least, it's likely to be warm. So... let's start, shall we, as usual, Steve, by looking in the west as the sky darkens, and there you'll find...
Oh, the UFO.
Oh,
sorry.
Yes.
That's not a UFO, it's the planet Venus, which, it's so obvious.
Yeah.
And even, just after the sunset, it's distinctly bright.
And why do people think it's a UFO? Why is it mistaken so many times a year for being a UFO?
One, because it's bright.
Yep.
And... a phenomenon called parallax. So if you're driving along or walking along or anything else, it seems to move with you against the foreground objects. It followed me. and when you stop, it stops. But it does that for everybody all the time.
Yeah.
And I suppose for many people it is a UO, maybe not flying, but it's an unidentified object.
Yeah.
But you can identify it as Venus. So now it's an identified object.
And very, very bright. It's the third brightest object in the sky. Sun and moon first, but then Venus is the brightest object in the sky.
Although photographically, it's about 2 stops on a camera brighter than the full moon.
Yeah.
It is so intense.
Yeah.
It just doesn't cover such a great area.
And Venus, of course, is our sister planet, one planet in from us towards the sun, which means we can never see it in the dark sky. We can only ever see it as a morning star or an evening star.
Yeah.
And it's getting steadily higher in the evening sky. And every day during this month, it's getting closer to Jupiter. So as you watch during the course of the month, you'll see them coming closer and closer and closer together. And by the end of the month, they're going to be very near, aren't they?
Yeah. And next month, we'll talk about that then, they're going to be in what is called conjunction.
Yeah, around about the 9th of June. We'll talk about that. That's next month. But this is, of course, then your last chance to view Jupiter through a telescope, because by next month it really will have gone.
Yeah.
So have a look at it. Get your telescopes out. Point it at the planet and see if you can see those belts across the disk and those 4 moons.
The 4 moons, the belts, and you might get a glimpse of what's called the Great Red Spot, although it is no longer great nor red. It's
very, very hard to see.
Mediocre salmon pink spot.
Yeah.
Yes, and it's shrinking, I think. It's a storm that's probably been raging for at least 300 years.
Yeah. A bit like those storms we've had in the New Forest recently.
Oh, that felt like it was raging for 300 years. It was only a few.
What about the other planets then? We got any other planets? We got Jupiter, and I talked about Jupiter and Venus. What about the rest? We got any more to see?
Yeah,
this
but
month?
they're in the morning, and they're incredibly low and difficult to see. And that is because the path of the planets at this time of year in the morning is very, very shallow to the horizon.
Right.
In the evening it's steep. In the morning it's shallow. So they never really get above some pretty bright twilight. So
let's
you've got
forget them for now.
Saturn and Mars. And we can also, you can see Mercury, I suppose, a bit in the west, but it's difficult.
Yeah.
And so don't expect to do it. And if you are looking for any of these planets, using binoculars or anything else, just be very, very careful that you don't get the sun, because
Absolutely.
you definitely don't want to do that.
So we're going to expect to get Saturn and Mars into the evening sky by August time, I guess.
Yes, sometime.
We should be able to see them. But as we said, right now we just got the two planets, really, haven't we?
Yeah. And of course, in August, the part of the planet is shallower in the evening sky. So it's not brilliant for those.
Well, what about our nearest neighbour in space, then,
the
Steve?
moon, yeah. We got 2 full moons this month.
Oh. And us astronomers, the full moon is our worst enemy. Why is that? Because it swamps out all the light of the fainter stars and galaxies, so we can't do any photography. Yeah. When we get our telescopes out, everything's grey, milky because of moonlight everywhere. So we like to observe in the middle of the month, don't we? When there's a new moon or a little crescent, no full moons.
Although one blessing is at the end of the month, when we're sort of almost in June, that full moon on the 31st never gets very high.
That's true.
So it's we can at least escape the worst of it.
So in May, we got one on Friday, the 1st of May, right?
That's right, yeah.
And the next one is on the 31st of May. So we got 2 full moons in 1 month. Now, what's that?
Well, one of them is called a blue moon. Well, they usually now it's erroneously it's the second one they call a blue moon. It's the second full moon in a calendar month, which of course is named after a moon. It's a moonth.
A moonth, that's it. But a blue moon is not blue, is it?
It's
a moon will never be blue, will it? Never. Unless maybe forest fires, dust particles.
No, you can get a bit of blue on it if you get a total lunar eclipse. And the edge of the moon can be blue where it's getting light that's gone through Earth's ozone
But
layer.
we're just going to confuse listeners,
we're going to do that.
What we're going to say, right, fundamentally, no such thing as a blue moon.
as a blue moon.
Right. And why is that so rare? Well, it's because, the Earth orbits... Sorry, I'll say that again.
Yeah.
The moon orbits the Earth once every 29.53 days. So the chance of getting 2 full moons in a month of 30 or 31 days is pretty rare. In fact, it only happens once every blue moon. But that's not the original meaning of the expression, was it?
No. They used to still divide the year into quarters.
Yeah.
And
that was church, really, wasn't it, in many ways? Yeah.
And so what happens... Oh, excuse me. If you got 2 full moons, if you got 4 full moons in a quarter, because you'd normally only get 3.
Yeah.
One of those would become the blue moon.
Yeah.
And it wasn't the 4th one.
Most extraordinary.
No.
It was the 3rd one.
It was the 3rd one, yeah.
Yeah. So, but something changed. Back in 1946, there was a misprint or a misinterpretation in an astronomy magazine, and then a blue moon has now suddenly become the 2nd one in a full month. But anyway, so we have a blue moon in May.
Yeah. The moon's been in the news recently as well with Artemis II, which went round there. Most things worked well. The loo didn't, but well, something's got to go wrong, hasn't it?
Yeah. Well, at least it was only the loo.
Yeah,
and she fixed it apparently for our intrepid astronaut lady got her plumbing gear out and fixed it.
Yeah.
So.
Oh yeah. Well, they do have to be able to fix most things on there just in case.
Yeah. But unlike Apollo, because Steve and I'm looking at him, we're of an age that we remember Apollo, back all those 50-plus years ago. But unlike previous Apollo missions, this mission at Artemis II only did one quick loop around the far side of the moon. Yeah. And please note, it's not the dark side of the moon,
no,
because that's
Floyd.
A wonderful album by Pink Floyd. So they just did one trip out, 3 or 4 days, whip round the back of the moon, fly back here, and they've brought some spectacular photographs back, haven't they?
Oh, absolutely gorgeous. And they're the first people to actually be able to see the full disk of the whole far side of the moon.
Yeah.
So they went quite a long way beyond it.
Yeah.
The other ones, the Apollo ones, were much, much closer, and actually did some sums when Artemis was up there. They couldn't have seen more than 12% of the moon's surface at any one time.
Yeah. Because the Apollo guys were in orbit around the moon at a height of the most maybe 100 miles.
Yeah.
Whereas the Artemis II went past the moon by about 5,000, I think.
Something like that, yeah.
So like you say,
they went
could see the full
furthest from
disk.
Earth of any human being ever.
Yeah. And we should remember that number because it's 252,700 miles from Earth. Until the next time, that's the furthest that mankind and womankind has ever been from the planet.
Yeah.
Anyway, so we'll put some pictures of the Artemis moonshot on our Forest FM fan page, and wait anxiously for the next one. When's that? That's Artemis 3, presumably.
Middle of next year. This one, Artemis 3.
Yeah, but we haven't even got a crew named yet, have
no.
we?
Well, they don't need to. They'll probably be having a crew and a backup crew, because they always have a backup crew, just in case. If someone on your main crew gets ill or they're in isolation, then that crew will not fly.
Yeah, and that's what happened actually on Apollo 13, remember?
Yeah.
The command module pilot for Apollo 13 was going to be Ken Mattingly, and he got measles. If you remember from the famous film, he got measles and had to be replaced by the backup, which is a guy called Jack Schweigert. And Jack Schweigert flew that mission, and Mattingly then flew Apollo 16. Yeah. So he got a good deal out of it, a bit of measles for him, which, oh, by the way, he didn't get measles,
He didn't get measles, but also the original crew, which couldn't fly, were also the ones that were mocking things up and enabling Apollo 13 to actually sort some of the problems out, at least get over them and make it back alive.
Yeah, that's 1970. That's a long time ago, isn't it?
Yeah.
Good gracious, 56 years. Remember it like yesterday. Talking of yesterday, what about the comet? That's a comet of yesterday, isn't it? That's
Comet Dud.
Comet Dud. Mysteriously, it's called C/2026 A1 brackets maps brackets. Now, what's all that about?
Well,
why can't we just call it Comet Tonkin or Comet Hardaker?
Well, comets are usually named for their discoverer,
right?
And neither of us discovered it. So it's 2026 A1, so it was discovered in 2026. A means it's the first 24th of the year, so it's the first half of January. And the 1 means it's the first one discovered in the first half of January. And you're going to tell us what MAPS means, because
You said we meant to rehearse this, so I've no idea what MAPS means. I know that it's a mapping telescope that is used to identify these comets or find them, especially little asteroids, but I don't know particularly what MAPS is. Anyway, the discoverer was not a Steve or a Mark or any other astronomer. It was a mapping telescope. Therefore, these comets are named after the telescope, which is a bit of a shame. But that comet came whizzing in, passed very, very close to the sun around the 4th of April, and then what happened?
Oh, it disintegrated.
It just fell into bits. Oh, dear. And this is what we call sun-grazing comets. They're very, very difficult to predict. They fly in at high speed, come very close to the sun, and fall apart because they're effectively dirty snowballs, right?
Yeah. So they get boiled up by the sun, but also the sun's gravity can also rip them apart. So you've got two things, which are the sun's heat and the sun's gravity, which are giving the comet very, very little chance of making it round.
And what is a comet, Steve? What can we imagine it is?
Well, as you said, dirty snowball. So a load of ice with a load of grit in it. I think you described as, you've rolled a snowball down a dirty gutter or something like that. And as it gets closer and closer to the sun, and it usually starts actually when it's about up by the orbit of Mars, it starts gassing off. So some of the snow becomes steam, as it were. Yeah. And you can see that as a tail, and some of the dust comes off with it and reflects sunlight, and gives you its dust tail. And gradually, the comet will get weaker and weaker on every return if it does come back. But that's essentially what it is.
So it's frozen solid out there in the depths of space for eons and eons, falls in towards the sun, gets heated up. This tail billows out the back of it for a few weeks, maybe, a few months?
Weeks, sometimes months,
Okay.
Depends on the comet.
And then, in this particular case, it got so close to the sun that it was ripped apart by gravitation and the heat. So what we expected to see when it came out the other side of the sun was not there.
It was not there. It had disappeared.
So it left behind then a trail of that dust and pebbles and grime and grit from the gutter, did it?
Yep. And if that trail just happens to cross Earth's orbit, I mean, it's going to be orbiting the sun forever anyway.
Yep.
Well, not necessarily forever. If it comes into contact with...
Long time ever.
A planet, If it comes into contact with a planet or a planet's atmosphere, that dust falls in through the atmosphere, and that is what we call a meteor shower.
Aha. So I think we had one, didn't we, in April? Did you see any of those meteors, Steve?
No, because I knew it wasn't going to be very strong, and I had other things to do that evening.
And that's the other thing. Social media especially have pumped up these meteor showers to being, a meteor shower will lighten up the Earth, will dazzle astronomers. The Lyrids, as these meteors were called in April, the Lyrids, it's not an active shower, really. We get maybe 5 to maximum 25 meteors per hour.
Yeah. I have a meteor camera, which is a part of a global meteor network. And it covers quite a large part of the sky. And it caught, I think, 38 meteors that night, of which only 25...
During the course of how long? The whole night?
The whole night, but it's not covering the whole sky.
Right.
It's only covering an area of about 90 degrees right angle by half a right angle. So
Right.
Yeah.
But that gives you an idea. If you've got, let's say, 10 per hour, that's one every 6 minutes. You're lying. That's on average, and that's under good conditions, right?
And if you can see the whole sky at once.
Yeah, if your eyes could look up and see 360, which we can't. And if there was no cloud, which there never is, and if there was no light pollution, which there always is, then you'd get maybe 10 an hour. So it's not spectacular. Yeah. But it has happened that these Lyrids have produced big showers in the past, Steve, right?
They have done. You sometimes get denser bits in the debris trail that the comet leaves, so yes, you can get that.
Yeah.
But we've got another one in May, actually.
Oh, right. What's that one?
It's called the Eta Aquariid.
What's that mean?
They appear to come from near a star called Eta Aquariid.
Yeah.
Which takes a long time to get above the horizon at this time of year. So it's not going to be very favourable. So on the 5th, but have a look. But you're going to have a lot of moon in the sky, so you're really going to want to look before moonrise, because once you've got moonrise, you're not going to see anyway.
Yeah, we often classify these showers as being favourable or unfavourable. Favourable usually means there's no moon. So the Eta Aquariids, not good this month because of the full moon. The Lyrids last month, they were particularly good. And this year, come August, many of you will have heard of the Perseids. This is going to be a very, very good year for the Perseids, because we have a new moon even just a few hours before the Perseids maximum. So more about that in August. It's going to be a very, very busy August for astronomers, I'll tell you that much. Lots going on. So the Eta Aquariid, do they come from the same comet then as the Lyrids? Is that, or a different comet?
No, that's a different one. That's the most famous comet that everybody's ever heard of. Comet Halley, or Halley, depending on how you pronounce it. I reckon it's Halley because he sometimes spelt it with a W. But what it wasn't was Halley.
Right.
Bill Haley in the Comets, that was his
That's one L
name for his
in
band. That was one L.
Yeah. So I think I'm going to start saying Comet Halley too, but... Yeah,
we all grew up saying Halley.
Halley's Comet. Yeah, Patrick Moore used to say Halley, but he did change it towards the end of his life. I think somebody leaned on him to say Hawley. But so these Eta Aquariids are trails or bits of debris left behind by Halley or Hawley as it's orbiting the sun once every 76 years, right? So... what about then, we've got the night sky. The spring constellations are just about done. So the summer constellations are coming up in the south, right?
Yep. And so late in the night we will see basically the summer triangle, which is one of my favourite bits of the sky. But before that, still look for Leo, which is going to be in the southwest once it's dark.
Yep.
Beyond that, we've got Virgo, and above Virgo, just behind the Lion, we've got Comet Berenices, which you can, in a dark sky, what you will see in there is there's a sort of faint fuzzy glow, which is actually quite big.
Yeah.
And that's what gives it its name. It's Berenice's hair.
That's it.
This is what Comet Berenices means.
A very nice cluster of stars in the sky. Beautiful with binoculars. Absolutely fills your binocular field of view.
It's stunning in binoculars,
it really is.
Isn't it? Yeah.
Anyway, let's look to the east. So we're facing the east now, and we see the first of these three stars, the summer triangle. You've got brilliant Vega in the constellation of Lyra. That's coming up, a steely blue white star, and that's the fifth brightest in the entire sky.
Yeah. And then just below and to the left of that, you've got Deneb, which means tail, and that's the tail of Cygnus the swan.
Right, so if we've got we can't miss Vega. So then below and left of it is Deneb, and below and right of it, further down, is Altair,
which rises quite a bit later.
Yeah,
that's in the constellation of Aquila.
Aquila,
so which I've been talking about.
Yeah,
and it's they're going to be with us throughout the summer. They're sort of overhead around midsummer. It's a good time to look at them. So we'll talk more about them then.
Yeah. So now, we're facing east. Let's swivel a bit. Let's go turn to our left. So we're now facing due north. Now, normally you'd see the Plough there, wouldn't you? Low down. Yep. But of course, at this time of the year, because the Plough changes its position during the months, the Plough isn't low at the horizon anymore.
No.
It's high in the sky to the left, right?
Yeah, I mean it's almost overhead.
Yeah,
it's nice and bright.
Yeah, you can't miss it. Of course, it's only one part of the large constellation of the Great Bear, or Ursa Major.
Yeah.
And from our latitude in the northern hemisphere here, where we are in the New Forest, the Plough is always visible. You'll always find it in the sky. Point north and then look up left and right. You'll see it there somewhere. And we call it a circumpolar constellation, which means it never sets.
It circumnavigates, so it goes round the pole.
He's great in Latin, He's well educated, Mr. Tonkin.
Yeah, as if you're not. Yeah.
So the planets and constellations that we've mentioned today can all be seen on our monthly sky chart, which you'll find on the Forest FM Facebook fan page, as well as online at Fordingbridge Astronomers, Wessex Astronomical Society. And that chart this month will show the stars around the 15th of May. And you can print it out, you can hold it above your head and use it as a guide to the night sky. And if you're interested in finding out more about astronomy, it's a great hobby. It really is. Can't you tell from our excitement in our voices? It's great.
Yeah, and I've been doing it for most of my life, and I'm still
excited.
Yeah.
So but the best way to start is to join your local astronomy club. You don't even have to join; just come along.
Come along. Yeah. So first of all, it's Fordingbridge Astronomers, and we meet every third Wednesday of the month, and that's in the barn at the Elm Tree in Hightown in Ringwood.
Yep. Then we have Wessex Astronomical Society. They meet at the Allendale Centre in Wimborne on the first Tuesday of every month.
And then lastly, there's the Cranbourne Chase Astronomy Club, which meets the second Wednesday of the month at the Grosvenor Hotel, which is in Shaftesbury.
Absolutely.
Nice venue.
Great place to go, yeah. And all those clubs, and all the clubs throughout the UK, welcome new members. You don't need any expensive gear. You need just an eye and a thirst for knowledge and have a bit of a sense of humour too, really.
Yeah,
it does help.
It does help,
as you can tell with us too. So we look forward to seeing you next month in June for another edition of Starry Skies. And until then, it's goodbye from me, Mark Hardaker.
And from me, Steve Tonkin. And as usual,
clear skies.